am Devi. I am working as assistant professor in the Department of AI/ML. I am working in the Hindustan College of Engineering and Technology. Today my subject is artificial intelligence for cyber security. My topic is cyber security in IOT architecture. So these are the contents today. I discussed a definition of IoT security, IoT architecture of IoT, IoT security challenges. Under the IoT security challenges, weak authentication and authorization, lack of encryption, vulnerabilities in firmware and software, insecure communication, difficult in patching and updating devices. So normally all of you know about what is meant by IoT, Internet of Things. In the Internet of Things means it is a hardware. There is so many sensors. So using the sensor you have to gather the information. So instead of IoT, how the securities have to be maintained. First definition of IoT security. IoT security is based on cyber security strategy to protect IoT devices and the vulnerable networks that connect to form a cyber attacks. IoT devices have no built-in security. IoT security is needed to help prevent data breaches because IoT devices transfer data over the internet and unencryption and operate undetected by standard cyber security systems. So in the IoT devices, the major disadvantages is the data is not encrypted and undetected by some drawbacks will be happen. That is the major disadvantages in IoT. That's why we have to go for cyber security. Next topic is architecture of IoT. So in the bottom to top, first one is perception layer, network layer, support layer, application layer. Perception layer means there is a sensor, RF reader, RFID reader and GPS tracker. Network means it is an internet portable communication and communication protocol. Support layer means we have to storing the information through the smartwatch, smart computing, cloud computing, etc. Application means application layer is nothing but the user friendly smart transportation environment observing information services. In the bottom one is perception layer. The perception layer is also referred to as recognition layer. It is the basic level which gathers all type of information with the help of physical equipment, that is sensors and GPS and these other things, and identify and read the external world. The information from the device sensor includes the properties of the objects or the things, the environment condition and more. The physical equipment like RFID reader, GPS, all kinds of sensors and the other equipment comes under this layer. In this layer is the sensors that used for capturing and representing the physical world, that is the data given by sensor connect to this layer. The next layer is network layer. Network layer means all of you know it connects between from one to another. The layer connected to broadcast data and data collected on the numerous essential networks like mobile communication network or Wi-Fi networks, satellite networks and etc. This layer is responsible for providing the dependable broadcast of data that we get from the previous layer. Most importantly, the data gathered from sensors broadcast to the next level for it to be processed. The next level is called sensor layer. The initial handling of data collect through the sensors, cataloging and polymerization. In the bottom to top, the third layer is called support layer. This layer acts as the mediator between the upper layer and the lower layer. Here the lower layer is perception layer, upper layer is application layer. Consider it as the platform for setting up a proper application layer, as it helps with merging the application upward and network layer downward. Example, grid and cloud computing used like all kinds of creative computing powers. So last one, it is the top of the layer. In this layer, the personalized delivery of application happens whatever application the user is presented, which is taken off in this layer. It can be from smart water, smart transportation, smart environment, support smart air system and more. Example, it can be done through computers, mobile devices, televisions and etc. The next topic is IoT security challenges. So, what are the challenges that faces for IoT? IoT weak authentication and authorization, lack of encryption, vulnerability in firmware and software, insecure communication, difficulty in patching and updating devices. The next one is lack of encryption. The overwhelming majority of IoT devices network traffic is unencrypted, making confidential and personal data vulnerable to malware attacks such as ransomware or other form of data breach or theft. This is called lack of encryption. Then the next one is vulnerabilities in firmware and software. Vulnerabilities in firmware and software. What is mean by firmware here? Here firmware means it is a form of microcode or some program embedded into hardware device to help them operate effectively. That is called as firmware. Examples for hardware are cameras, mobile phones, television, sensors. These are the example for firmware. Now, how the vulnerabilities in firmware and software. The short development cycles and low price points of IoT device limit the budget for developing and testing secure firmware. Without this built-in IoT security, IoT devices are vulnerable to the most rudimentary forms of attack. From firmware to software and third-party apps, millions of devices are affected by vulnerabilities in standard components. The next challenge is insecure communication. IoT devices are often connected to the same network as other devices. IoT manufacturers don't focus on building IoT security into their device to make hardware tamper-proof and secure. Many IoT devices are not designed to receive the regular IoT updates, which makes them vulnerable to attacks. So today topic we are discuss about what does mean by IoT security, architecture of IoT. There is a 4 layer is there, bottom to top. First perception, then network, then session layer, then application layer. Then we go for IoT challenges. So these are the cyber security in IoT architecture. Thank you.